Okay, thank you, everyone. This presentation is about the llvm debuginfo-analyzer. It's a new tool added to llvm. Oh, sorry. The presentation is divided in 3 sections. One is initially an introduction about llvm and debuginfo. Then some useful command line options to print, select, and compare. And finally, main areas for future work. Common problems with debuginfo. There are mainly 2. First one is, does the debuginfo represent the original source code? Like, for example, which variables are dropped due to optimization? Why I cannot stop at a particular line number? Which lines are associated to a specific code range? And any size changes due to features on the tool change. And one important one is the semantic differences in the generated debuginfo. When the same source code is compiled on the same platform with different tool change, or on different platform with the same tool chain or different tool chains. This is an example of a debuginfo issue detected by GDB due to a bug in CLAN where an incorrect lexical scope was detected. So at line 3 and line, we are expecting unsigned, and it was reported as float. Let's move to the llvm and debuginfo. llvm supports multiple debuginfo formats, such as DORF, CodeView, in different binary formats, ELF, COV, PDB, MacO. And the output from tools such as DORFDAM, PDB-util, readosh, they use a close representation of the internal debuginfo and requires a good knowledge of these formats to understand their output. Plus, understanding the mappings between source code and debuginfo can be complex, and it's a common problem when triaging debuginfo issues. Debuginfo formats. On this slide, we have on the left a small simple test case. In the middle, we have the DOR representation, and on the right-hand side, the code view. The formats are different. They use different layouts, different names, different values. So this is the equivalence between the COV and between the DOR and the code view. Let's move a little bit the introduction about the debuginfo analyzer tool. It's a command line tool that processes debug information contained in a binary file, and it produces a universal representation that we call it logical view. It's a high-level semantic representation independent of the debuginfo low-level format, and is composed of the traditional programming elements such as scopes, types, symbols, and lines. So in this presentation, when I mention logical elements, means any of those scopes, types, etc. Key features. There is a uniform logical view regardless of the debuginfo and binary file formats. The logical lines are associated to their logical scopes. We can use criteria to select which logical elements will be included in the final logical view. And finally, we can find semantic differences by comparing the logical views. This is the normal standard development workflow. So we have different inputs, different tool change, different outputs, and at the very end, we have the tool. So taking different kind of formats and producing just a universal representation. This is an example of the logical view. And in this case, we can see that at the scope number 3, we have 2 type definitions with the same name, but different underlying type. Let's see side by side the 3 formats. On the left, we have the DORF. In the middle, we have the logical view. And on the right-hand side, the code view. So this is where we can see the mappings. Let's move to the second part of the presentation. We are going to cover a set of useful command line options to print, select, and compare logical elements. We use a recent version of Clan on Windows and Linux. We compile the same test case with -G0 and -G02 to generate CodeView and DORF. For the presentation, the layout of the slides are on the top left, you will see the test case, on the bottom left, the command line options. And depending if we are on print, selection, or comparison, the middle or right-hand side will be different. We are going to print options for these logical views, those combinations. So we are going to call DORF0, means -G0 DORF. Let's say CodeView will be on Windows, CodeView 0, and so on. So let's start with DORF0 and DORF02 side by side. So we can see on the middle the logical view for 0, and on the right-hand side the logical view for 02. Interesting since at 0 we can see multiple entries for the logical line 4 and different code generation for line 3. Let's do the same command line options, but now CodeView 0, CodeView 02. We can see that at 02 the variable index and the lines 4 and 7 are dropped. That's due to optimization. Let's do now DORF 0 with CodeView 0. Interesting points is that the code view generated by Clan and Microsoft, the Visual Studio, they don't include any line information for the logical symbols or functions. And you can see on the left that the DORF include the lines. That is a big limitation and it's cause a lot of problems for comparison. Let's do now DORF02 and CodeView 02. So we can see that DORF generates multiple entries for line 5 and only one single entry for line 5 on CodeView. Let's move to selection. Normally when you generate a logical view, if your input is quite big, the output will be massive. So the tool supports what we call selection. You supply a criteria, and the logical view will include only those elements that meet that criteria. For the following slides, the layout changes a little bit. So in the middle, just for reference, we are going to have the logical views, and on the right-hand side, the selected view based on the criteria. And then we are going to use two different output layouts. One we call list, which is like a tabular way, and the other one is view, which is including all the different scopes. So let's start. For this particular case, we have the selection is index or 4, meaning that the logical view will include any scope, symbols, or lines if their names contains the index string or the line number is 4. So in this case, we have for DORF0 and DORF02 that the output on the right-hand side is including only lines which number 4. And for 02, just a variable called index. And as a view, the only difference with the view is that those elements are within their logical scope pattern. So now let's do, this is DORF2, has a view layout. Let's move to CodeView 0, CodeView 02. Same criteria. So that is the output. Interesting case that although 2, there is no lines, there are no symbols that meet that criteria. That is as a view. Let's move now to normal selection. Sometimes can include too much information because you can have the same name associated with two different things. You can have a foo as a function and a foo as a member, or as a foo as a class, etc. So we created something called combined selection. Combined selection means it's an extension of the simple selection. The only thing that includes the kind of logical element. Kind can be, you can have a scope that can be a lexical block, a function, an inline function, and a structure or something. So I can say, give me all the scopes that are functions and are named foo. So that is the idea for this part of the presentation. We are going to use two selection criteria. One is, I want to print only lines that are debug lines, and the line number is 4. And I want to include, for another case, those symbols that are variables, and their name is index. And again, we use two different layouts for the output, list and view. So for the first case, we have only lines 4. And in the lower part, we have variable index. This is as a view representation. Then do the same thing with CodeView 0 and CodeView 02. So we have a 0, 2 lines 4, and an 02. There is no logical elements that meet that requirement. This is the view output. So, but still, you have the problem that even with selection, it's very difficult to see what are the differences or what is missing. So one important feature of the tool is doing semantic comparison. So we can find those semantic differences in debug info produced by different toolchain versions or even different debug information formats by comparing the logical views and printing those elements that have been added or are missing. For this part of the presentation, the layout change again. In the middle, we have the logical views only for reference, and on the right-hand side, we have the comparison view. So let's start now with, we are going to compare DORF 0 and DORF 02. So what we can see in the output is you will see some minus signs and some plus signs. The minus means elements that are missing, and the plus elements that are being added. So the information is going to be, and so we have here for 02, there are missing 5 lines number 4 and 2 lines number 7. Important is the view layout. The view layout is like a merge of the first logical view with the second logical view, showing what is missing or what has been added. That is very useful because you can see on a specific logical scope what can be missing and what can be added. So we follow. This is view layout. Now we are comparing CodeView 0 with CodeView 02. We can see that there are missing 2 lines number 4 and 1 line number 7. The same as view representation. So we can see the lines number 4, they have the sign, the minus sign, and the line 7, the minus sign. So we are comparing now different debug information formats. We are comparing DORF 0 with CodeView 0 as a list layout. So because CodeView doesn't generate the line information for symbols and scopes, then in this specific case, foo is being detected as a missing, as an added, because there is no way to distinguish between one and the other one. So that is a big limitation currently with the CodeView implementation in Clang. So that is the output as view layout. Now let's compare it, DORF02 with CodeView 02. And as a list view. So because we are using the same test case, the output is supposed to generate the same information. That is why it's universal. And doing a little bit of summary in general, we have covered common problems with debuginfo and llvm and debuginfo. We have covered the debuginfoanalyzer, which is a command line tool that processes debug information. The important important aspects are that the logical view is a universal representation independent of the low-level encodings of the debug info. And we can find semantic differences and so on. Future work. The README file contains notes that were collected during development, review, and it describes limitations, known issues, and future work. What we believe is important now is these 4 aspects, the first one is add support for another binary formats, like a WebAssembly and extended COF. Second, generate the logical views in a format which is standard, like a JSON or YAML, because at the moment uses a free form. And process additional debug information, especially in DOR5, the debug name section, and in CodeView, the public symbols stream. And finally, support relocatable files, which are those objects where each function is always in a different section. This project has been quite long time, and there was a lot of reviews, and I would like to extend a big thank you to the people that in one way or the other one have made possible for this tool to be part of llvm. They contributed with reviews, feedback, suggestion, and testing. So thank you for listening.
All right, thanks for the great overview of the tool.
Thank you.
Any questions?
No questions.
Sounds like.
What would be your motivating example for using this other than to see that there's differences between 2 formats?
Sorry, say again. Is it?
What would be a motivating example for the tool other than to see that there are differences between 2 debug formats?
The main motivation was to figure out what is, regardless of if you are using, regardless of the debug info format that you use, the main motivation was to find out what was happening when you are doing optimization, because it's very difficult to follow what is missing. That's the main motivation. Is because you enable one option and suddenly you cannot debug because this line disappears, this function is not there, the variable is not there. So it's a very difficult by looking at some very strange low-level format, what was going on. So that was the main motivation. And doesn't matter if you are using DORF or CodeView or anything else. That was the main motivation.
Hi, just out of curiosity, did your work result in feedback or improvements, suggestions to DOR5 or CodeView standards? Did you find anything that would help make DOR5 or CodeView more complete, give a more better debug view?
Yes, so far is basically the DORF is a very well-known format. It's been there for years and years and years. And in the specific case of PDB, that information was private, and now it's become a little bit more public. So there is a lot of limitations on the code view that makes that format a little bit difficult to, like for example, the case that I described with the lines, no? So one of the issues will be basically to start taking the same source code, compile it on Windows, compile it on Linux or something, and then start going one by one and see. You cannot do 100% mapping between those two, but you can figure out in a more or less quite accurate way what it will be missing, not by the formats, but the implementation of those formats by the compiler. Because the formats are completely different, but you can say that it's more or less one-to-one. So that is but it's a massive exercise, no, for